Hello students, myself Dr. Sofia Gupta. Now we'll discuss the part 2 of molecular orbital theory. In this part, we will basically cover the examples of various molecules, and also we'll discuss about bond order, magnetic properties, and further more things. Now, firstly I'll tell you basics of what is bond order, magnetic character and magnetic moment and how to calculate them. Okay. Now first is bond order. So in order to calculate the bond order, what is bond order? Like this is simple ethene molecule. Here the bond order of carbon is 2. Number of bonds which are present is known as the bond order. Like if there are 2 bonds present, 2. If there are 4 bonds present, then the bond order is 4. Okay. Now how to calculate the bond order? It is bond order is equal to half the number of bonding electrons minus the number of anti-bonding electrons. Okay. Then is magnetic character. Magnetic character. Okay. So in the magnetic character, basically we have to tell whether the molecule is paramagnetic or it is diamagnetic. Okay. So what is paramagnetic and diamagnetic molecules? If there is any unpaired electron present in a molecule, then it is paramagnetic. Unpaired electron present, then it is paramagnetic. If all the electrons are paired, then it is a diamagnetic molecule. Then the third is magnetic moment. Okay. So the formula to calculate the magnetic moment is under root of n plus 2 bm. Bm, it's a unit of magnetic moment. It stands for Bohr magneton. And what is n? N is the number of unpaired electrons. I hope this is basics is clear to you. Okay. Now before starting with the molecule, I'll tell you a basic diagram how to draw it. For example, you are having a B2 molecule. Okay. What is B2? It's a boron molecule. We know that atomic number of boron is 5, so it is having 5 electrons. Total number of electron is 10. Okay. So what rule is followed? It is the case 1 that we have discussed in part 1. Okay. So see, it is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, total 2, 4, 6, 8. Then is pi 2px is equal to pi 2py 1, 1. Because these are degenerate orbitals, so we have studied according to Hund's rule. First is filled, then second, so 1, 1. Okay. Now how to draw a molecular orbital diagram? See, basically we will consider this valence shell electron. See, it is having 2 shells. First, this is 1 K shell, that is 1, and M shell, that is 2. So basically we will consider this valence shell for drawing the molecular orbital diagram, because these shells are the shells whose electrons are involved in bonding. So let's start. We are having boron. Okay. So you have to keep one boron here and other boron on the other side. Sigma 2s and sigma 2s. We know that boron, the electronic configuration of boron is 1s2 2s2 2p1. Okay, so this is the valence shell, so we'll consider 2s and 2s of other boron. The energy levels are equal, like this and this are of सेम एनर्जी लेवल. ठीक है, अब देखो, नाउ देन 2p1, वी नो दैट 2p is p is divided into 3, px, py and pz. Similarly over here, px, py and pz. So this is 2p and this is 2p. Now we are having 2 electrons in 2s, 2 electrons in 2s, here 1 electron, right? Now we know that when atomic, now see, these are the atomic orbitals, this atomic, these atomic, these all are the atomic orbital. We know that when the atomic orbital is combined, molecular orbitals are formed and they are formed in the same number. Here 2 atomic orbital combined, so it will give 2 molecular orbital. See, one is bonding molecular orbital and other one is anti-bonding molecular orbital. This is sigma 2s, this is sigma star 2s. ठीक है, total how many electrons we have to fill? 2 of this and 2 of this, so total 4 electrons. So we have to start from the lower molecular orbital, 1 2 3 4. According to the of-course principle, we have to start from the lower. This is the of lower energy, then this is of higher energy. So firstly we'll fill this and then we will fill this one. I hope that is clear. Now for the 2p, we know that there are 3 p orbitals, there are 3 p orbitals over here, so total 6 atomic orbitals are there, so they will give 6 molecular orbitals. You have to draw like this. These are lower in energy and this will be of higher energy. Okay, now we have one electron, total 2, so 1 over here and 1 over here, because these 2 are degenerate orbitals. So firstly we will fill 1, then 1. If we are having 3 or 4, then pairing will take place. I hope that is clear. Now to calculate its bond order, we know that it is half the number of bonding and minus the number of anti-bonding electrons. So it is half how much bonding, this bonding है ना, bonding electrons. So 1 2 3 4, anti-bonding this 1 2, so the bond order will come 1. मतलब there is single bond between boron and boron. Then you have to tell whether it is paramagnetic, diamagnetic. It is having the unpaired electron, so it is a paramagnetic. Magnetic moment is n plus 2. Now here number of unpaired electron is 2, so magnetic moment will be 2 into 4 under 8 Bohr magnet. Okay, similarly we'll solve different examples. For example, O2 molecule. We know that in a O2 molecule 8 plus 8 16 electrons, so you will get this type of diagram. In 2s, what is the electronic configuration? 1s2 2s2 2p2. Okay, so 2s2 2p 2 4 6, no, its atomic number is 8, so it is basically 2p4. okay, this one 2p4. Now you have to fill this diagram. This is a case 2 of in the electronic configuration. Okay, this diagram you have to draw similarly as I discussed of boron. Just this orbital will come upward and this will come downward, because this was the case 1 and this is a case 2. Now you have to fill here 4 electrons here. 4 plus 4 8, 2 3 4 5 6 7 8, right? Now we have to calculate the bond order. So the bond order will be half number of bonding minus number of anti-bonding electrons. Now number of bonding, how much? 1 2 3 4 5 6 7 8. See this one, 1 2 3 4 5 6 7 8. So you're having 8 bonding. Anti-bonding is 1 2 3 4, so 4 this, so you'll get 2 bond order. This is a bond order. Okay, so clearly you are having unpaired electron, so it is paramagnetic, and number of unpaired electron is 2, so mu will be 2 plus 2, that is 2 into 4, that is root 8 Bohr magnetron. Okay, similarly this boron I have told you in this example. So same is the diagram that you are getting over here. The question will come of bond order, magnetic property, and how to calculate the magnetic moment. Then up to this point we have discussed basically homonuclear molecules. Now what is homonuclear molecules? The molecules which are same, like H2, F2, O2, B2, these are the homonuclear molecules. Now what are heteronuclear molecule? Heteronuclear molecules are those which are having different atoms, like H, O, N, O, OF. These are what? Heteronuclear molecule. So we will discuss now how to draw the molecular orbitals of the heteroatomic molecules. Okay, let's consider an example of NO. So what first task is to calculate the number of electrons. In NO, nitrogen is having 7 and oxygen is having 8, so total of 15 electron. Now this is less than 16 electrons, so we will follow the case 1. See, the diagram is drawn according to the case 1. In this, the main point that you have to notice in NO, O is more electronegative than nitrogen. Okay, so basically when we are drawing the energy levels, the more electronegative species will have lower energy level than the less electronegative species, like nitrogen here, oxygen here. Now nitrogen is having higher energy level and oxygen is having lower energy level, 2s. Similarly for the 2p, nitrogen is having higher and oxygen is having lower energy level. Their energy level is different, all the other things are similar. Then you have to draw the diagram, then you have to fill. We know that nitrogen electronic configuration 1s2, 2s2, 2p, 3. Similarly oxygen is 1s2, 2s2, 2p, 4, right? Now we'll consider the valence shell. 2s2, 2s2, both are having 2s2, so total of 4 electrons will fill 2 over here and 2 over here. Okay, then is nitrogen having 3p electrons, or you can draw like this, simple, is having 3p electrons, p 1, 2 and 3. Similarly oxygen is having 4. Okay, so total is 4 plus 3 7. Then you have to fill like 1 2 3 4 5 6 and 7. Now the question will come to calculate the bond order, magnetic moment and everything, So firstly, what is the bond order? It is half number of bonding. See, 2 6, 2 plus 2 4 plus 2 6 plus 2 8 minus anti-bonding 2 plus 1 3, half 5, this is 2.5. Now it is having unpaired electron, so it is paramagnetic, right? Then how much unpaired electron? 1, so mu will be n plus 2 Bohr magneton. This is 1 plus 2 3, so root 3 Bohr magneton. Okay, so basically in the heteroatomic molecule you have to just draw the energy levels up and down. Which atom is more electronegative, that energy level you have to draw down. So and you have to keep it on the right hand side, like oxygen is on the right hand side and nitrogen is on the left hand side. I hope the concept of molecular orbital theory is clear. If you are having any doubt, do comment below in the comment section.